Hello to all of you. This is Dr. Dhaval Maheta, and today we are going to understand the fixed effects FEM or a least square dummy variable regression model to consider the cross-section effect in panel data regression. The estimation of the panel data regression model highly depends on the assumptions we make about the intercept, the slope coefficients, and the error terms. In general, the simple linear panel data models can be estimated using three different methods. One, with a common constant. Two, allowing for fixed effects. Three, allowing for the random effects. In the first case, assume that the intercept and the slope coefficients are constant across time and space, and the error term captures differences over time and individual cross-section units. That is known as a pooled ordinary least square. This method of regression we have already discussed in my previous video. Kindly refer my playlist to understand how to run this regression in EViews. So only one regression equation is considered for the entire panel data. Second, the slope coefficients are constant but the intercept varies over the individual. That is a fixed effects model. So we consider different intercept for the different cross-section units, but slopes are assumed to be constant. Third, the slope coefficients are constant, but the intercept varies over the individuals and time. The third possibility. Fourth, all coefficients, that is the intercept as well as slope coefficients, vary over individuals. And the fifth possibility. All coefficients, the intercept as well as the slope coefficients, vary over individuals and time. The same thing I have tried to represent in another format. You can see only one equation. It's known as a pooled OLS, ordinary least square. All intercepts same, all slopes same. In fixed effects methods, all intercepts are different based on time or cross-section invariant, but the slopes remain same. In case of third one, this one, mean intercept considered of all cross-section, but the slopes are different. In the fourth category, means are different and slopes are different. You can see here we have plotted on x-axis globalization index score and on y-axis emphasis on non-economic issues. So depending upon the country, we are having four cross-section units and four linear regression models are there. This I'll try to explain by a very simple example. Consider that the test grade of a student are dependent on the study time. Here, we are completely ignoring the cross-section unit, that is a student, or the time period unit, that is a test. So, it is a normal OLS. Y is equal to beta 0 plus beta 1 x1 plus the error term. So, our belief is that the test grade is completely dependent on study time. So, test grade is equal to the intercept plus beta 1 asterisk, that is multiplied study time. So, beta 1 is a slope plus error term. This particular type of regression, which is known as a pooled OLS, I have already discussed in my previous video. Kindly refer to it. Now, we want to introduce the effect of student in the test grade. So, we consider the intelligence of students into the consideration by using a fixed effect model. Now, how we can introduce this effect? Let's try to understand. Joe is a student, Sue is a student, and Mark is a student. Okay. Now, Joe, if I want to say that Joe is present, I will introduce the dummy Joe 111 and the absence of the Joe will be indicated by 000. Similarly, Sue, its presence will be indicated by 111 and its absence will be indicated by 000. So, if there are four cross-section units, we will create three dummies. Here there are four students, so I will create three dummies. Here, if I want to include the effect of time, then three time periods are there, three types of tests are there. I will include two dummies. The number of dummies are always one less than the number of units. The reason for this is that if we include all of them, if we make the dummies of all the cross-section units and we include in the regression model, then we will fall into the dummy variable trap, because of which our regression analysis will not be appropriate. Now, how to introduce a fixed effects model in our panel data regression? Let's see. Test grade is equal to beta 0 plus beta 1 study time plus beta 2 Joe plus beta 3 Mark plus beta 4 Shu. We don't consider Antonio because the cross-section unit or the student or the test whose dummy is not created, it will be captured by the intercept. Please make it a point. It will be captured by the intercept. Okay. So in the fixed effect method, the constant is treated as group specific. This means that the model allows for different constants for each group. The fixed estimator is also known as a least square dummy variable, lsdv estimator, because in order to allow for different constants for each group, it includes a dummy variable for each group. One way to take into the account the individuality of each company or each cross-sectional unit is to let the intercept vary for each company, but still assume that the slope coefficients are constant across the firms. So I'll say YIT, where I script stands for the cross-section unit and T stands for the time element. So YIT is equal to beta 1i plus beta 2 x2it plus beta 3 x3it plus mu it. So my error term is dependent on the time element as well as the cross-section unit. Now what happens if we run the normal pooled OLS? So we assume that there is a homogeneity in the entire data, but the things are not so. One size does not fit all. So a heterogeneity refers to the firm's specific characteristics and the period characteristics. By pooling all of them together, firm specific and times period specific characteristics are subsumed in the error term BIT. This problem is known as the endogeneity, in which the error term gets correlated with one of the regressions. Let's try to understand this thing. In this model, suppose if I don't consider the effect of cross-section unit and time element, this error will enter into this one, and the error term will be correlated with the independent variable. This is not desirable. So what will happen is the third case. By pulling all of them together, the firm specific and time period specific characteristics, the error term gets correlated with one of the regressions. This causes estimated regression coefficients to be biased and inconsistent. As a remedy, we take into consideration firm and time characteristics in the model to reduce the unobserved heterogeneity. Now, how panel regression evolves? Say, for example, y is equal to beta 0 plus beta x plus error term. YIT is equal to beta 0 plus beta 1 xit plus error term, which is dependent on time as well as a cross-section unit. So time and cross-section regression is included, but what about the unobserved heterogeneity arising from this term? So we introduced two new error terms. Now this error term we will disintegrate into two. Let us see what these terms are. So the error term from time effect plus error term from cross-section effects plus EIT. So now my equation is YIT is equal to beta 0 plus beta 1 xit plus unobserved heterogeneity from time plus unobserved heterogeneity from the cross section plus EIT. Now how to do the accountability of this unobserved heterogeneity? So YIT is equal to beta 0 plus beta 1 xit plus mu t plus wi plus epsilon it. So mu t is unobserved time-dependent error term, that is, the factors affecting y that vary with time but not across the firms. Example, improvement in the conditions. Omega is unobserved firm dependent upon the error term. Factors that vary with firm but are time-dependent. Example, location, corporate culture, dividend policy, capital structure policy, board diversity, etc. Now, YIT is equal to beta 0 plus beta 1 xit plus mu 2 omega I plus epsilon it, that is an error term. So, mu t is fixed over cross section but varies with time. Omega is fixed over time but varies with cross section. Now, how to do the accountability for this heterogeneity? So, we will introduce the lsdv model, that is a least square dummy variable. So, YIT is equal to beta 0 plus beta 1 xit plus beta 2 d1i plus b3 d2i plus mu t plus epsilon it. So, if there are three firms, I have already talked about this, we will introduce the two dummies to capture the heterogeneity of the cross section. So now omega I is equal to beta 2 d1i plus b3 d2i. So the dummy variable trap is that when we will include all of them, as a dummy in our model, we will fall into the dummy variable trap. So our final model will look like this. Yit is equal to beta 0 plus beta 1 xit plus b2 d1i plus b3 d2i plus vit. So there are three forms and we are only including two dummies here. Vit is equal to mu t plus epsilon it. Vit is a idiosyncratic error term. It is used to describe error, that is unobserved factors that impact the dependent variable from panel data that both changes over time and across the units. So the lsdv model accounts for heterogeneity by allowing the intercepts. So now how this dummy variable works? So if the firm 1 is present, so d1 will is equal to 1 if firm 1 is present, otherwise 0. d2 is equal to 1 if firm 2 is present, otherwise 0. I'll explain to you all these things when we'll be running EViews. Firm 3 will become the reference category. I had already discussed this thing that Antonio becomes the reference category. Beta 0 is time invariant. So yit is equal to beta 0 plus beta 1 xit plus beta 2 d1i plus b3 d2i plus mu t plus epsilon it. So for firm 3, d1 is equal to d2 is equal to 0 and whatever the thing is there, it will be captured by the intercept. For firm 2, d1 is 0. So yit is equal to beta 0 plus b3 d2i. For firm 1, d2 is equal to 0. So yit is equal to beta 0 plus beta 2 d1i. So coefficient from fixed effect model produce estimator known as a fixed effect estimator. This is one-way fixed effects model, also known as analysis of variance model, because intercepts vary across the firms but not across the time. Now let us see how we can do the same thing in EViews. We have already discussed about this data. This data has been taken from the book Damodar Gujarati Basic Econometrics. Now first of all, let us see the data. I'll select observation x2, x3, y, year, open as group. Now you can see here there are four cross-section units: G, GM, US, and Westinghouse. Now I want to introduce the dummy. Four cross-section units are there. Can you guess how many dummies will be there? Right, one less. So three dummies will be there. Let us introduce the effect of this. So I'll keep this thing aside and I'll go into quick generate series. D2 is equal to 0. Make one thing sure, we'll make G as a reference category. So D2 is equal to 0, click OK. Again go here, quick generate series, D3 is equal to 0. Quick generate series, D4 is equal to 0. We will create one less dummies. Now I will pick up observation D2, D3, D4, open as group. Now I want to create the dummies. For the reference category, I will not create any dummies. That is, I will not indicate anything. So its coefficient will be captured by the intercept. Now to indicate that GM is present, I'll go here, edit, and indicate everything by 1, 1, 1. Now you can see here, wherever GM is present, I have indicated its presence as 1. Then for in second dummy, I have indicated here 1, 1, 1. And in the third dummy, so three dummies are there, 1, 2, 3. I have named it as D2, D3, D4 because D1 is we have kept it for the first category, that is G, but we have not considered here, right? So 1, 1, 1 is considered for Westinghouse. Now how we will run this fixed effect model? So for this, I'll go in quick estimate equation and I'll write down here y c x2, x3, d2 to include the cross-section effect and d4. Enter. And I've got the result. Now I'll copy this result into the Word file, copy, and I'll write the interpretation. First of all, see the p-values of all the dummies, d2, d3, d4, x2, x3. They are all less than 5% level of significance, that is 0.05, and therefore we can say that the cross-section effects is significant. So, how we will write the interpretation? All the estimated coefficients are highly significant as the p-values of the estimated t coefficients are extremely small. The intercept values of 4 companies are statistically different, that is minus 245 for G. Now, why this is for G? I had already explained about this matter, that if there are 4 cross-section units, we create 3 dummies, and the cross-section unit whose dummy is not considered, it is captured by the intercept, the constant term. So this is for G minus 245. Now how to derive the intercept for GM? So it will be minus 245 plus 161 for GM. So you can see we get it minus 84. Now what will be for US? It will be minus 245 plus 339. You can see here. It is for US. What will be the intercept for Westinghouse? Minus 245 plus 186. So it will be minus 59.2258. That will be for Westinghouse. Okay. This differences in the intercept may be due to unique features of each company, such as differences in management style or managerial talent. Now we want to see that are these dummies are significantly different from each other or not. So for this, we will be running the Wald test. Again, I'll go back here. I'll go in view. And I'll activate this Wald coefficient restrictions. And I'll write down here C4, which is for dummy, is equal to C5, is equal to C6, is equal to 0. Enter. And I got the p-value for this Wald test, which is less than 0.05. Again, I will copy this and take it into the Word file. Now, what will be the null hypothesis of this test is, null is pooled regression model is better, all dummy variables equal to 0, or all individuals have same constant. The alternative is fixed effect model. The dummy variable exists. All individuals have different constant. So here, as the p-value is less than 0.05, which means that the null hypothesis is rejected. So fixed model effects are present, dummy variable exists, and cross-section effects are present, and we cannot run pooled OLS. We will have to go for fixed effects model. Now there is another method also in which I can run the panel regression considering the fixed effect model. So I'll again go back here, minimize this, close this, yes, this is not necessary. Quick estimate equation, y, c, x2 and x3. Okay, click go in panel options and activate the fixed effects from here and click OK. Now I'll copy this result again, copy, and I'll take it into the Word file. Now you can see here the coefficients of x2 and x3. Just focus on coefficients of x2 and x3. So x2 is 0.107 and x3 is 0.346. Let us see, is it the same thing which I am getting it? x2 0.107, x3 is 0.346. But the intercept is different. Now why it is different and how we can get from minus 245 to this one by using this method minus 73. Let's see. Actually, both the coefficients are same. I have already explained this method that this is minus 245 for G, this one. Then for GM, it is this plus this. So I've just copied this thing here, minus 84.220 for GM, 93.874. So I've copied this thing from here for US, and minus 59.2 for Westinghouse. Now, if I do the total of all of them, I will get the total as minus 295 plus 3964. If I take the average of it, it will be exactly same. If I take the average of this, it will be exactly same as this one, minus 73.84947. So this is a way you can run fixed effects models in EViews. For more videos on panel data regression using EViews, kindly subscribe to my channel. You can follow me on LinkedIn and Twitter. Please refer my playlist in which I have already uploaded many videos which are related to panel data regression using EViews. Thank you.